So in the last lecture, we looked at arrays, strings, and 2D arrays, right? Today we'll move on to the next topic, that is functions. So can anyone tell me what is a function conceptually? I mean, in simple words, what is a function? Yeah, quite simple in layman's language. A function is like a black box which takes some inputs and returns an output, right? So it's like a black box which takes some inputs and returns an output. This sort of schema, we also gave similar schema for the concept of a computer as well. If you remember the first couple of lectures, I said computer is also like a black box which takes some input and gives an output, right? So you can conceptually both are similar. Actually, that's the idea. Computer does some processing. It takes some input from the user, it processes it, and then it returns an output. That's all. Function also does that. But a computer sort of executes millions of functions, whereas a specific function does one thing, one kind of thing. That's the only difference. Otherwise, conceptually, both are same. We don't know what's happening inside. It takes an input, gives an output. That's all. And any function basically has sort of three parts. One is um, function declaration. Second is function definition. This is sort of similar to what you know about variables, right? And third is, any guess? Calling, yes, function call. That's all. First two parts, actually, each of these parts has equivalents with respect to variables also. In variables also, we declare variables, we initialize them, and then we use them later. Same thing in function also, you declare a function, you define it. Initialization is nothing but defining a function, and then you call that function later. That is using the function, right? So to understand it easily, so let me give you analogy with functions in mathematics, mathematical functions. Say, suppose I take two functions like say f of x equal to x square plus 5, um, g of x comma y, or let me use more meaningful names. Suppose let's say this is sum. This sum function takes two inputs and returns the sum of the two inputs, and let's say this is square. So it takes one input and calculates the square of that input, right? What are these called? I mean, what do they correspond to among the three things above? Declaration or definition? Definition. You're giving all the details. You are also getting inside the black box and seeing what the function is actually doing, right? You're not just using the function name. You're not just calling the function. You are not just declaring the function also. You're also telling what the function actually does, right? So you're defining what the function does. So these are function definitions. Okay. Now suppose I call them with some actual values, right? Suppose I say square of 5 and sum of say 12 comma minus 30. What are these? Are they declaration or definition or calling? You are calling. You see, when you are using specific values, you are calling, right? That function is defined, and then you are using that function on specific inputs. So using the function on specific inputs is nothing but function calls. Okay. Then what about declaration? Any guesses? What about declaration? Only declaration? Huh? Data type. We are not yet into programming, just mathematical functions. In mathematical functions, nothing to do with data types. Yeah? Just the name of the function and number of inputs it takes. So you are not telling what this function will do. You just know the name, SQ. You don't know what it does. You don't know whether it calculates square or it calculates square root or it does something else. It can be just f of x or g of x. You don't know what f is. You just know it takes one input. You know the function name is f. That's all. Similarly, here you know the function name is SQ and it takes one input. The next function, its name is sum and it takes two inputs. That's all. So you know the function name and the number of inputs it takes. Nothing more. So these are examples of function declarations. These are about mathematical functions. In programming, there are slight differences. We will look at that. But I hope you got an idea. When you are just specifying the name of the function and the number of arguments it takes, this is a unary function. It takes only one argument. This is a binary function. You can have a ternary function or an n-ary function. So that at least tells you the structure of the function. What is the name of the function and what is the structure of the function? It does not tell you what operations the function does on its arguments. That will be definition of the function. In this case, you just know the name and the number of arguments it takes. You're just declaring. Okay. If you get into the details of what exact operations it performs on its arguments, that is like getting into the definition of the function like this. I know I take x as my input, but what do I do on that? Do I do x cube or x square or x plus something or minus something? What operations I'm performing? I don't know. When you specify that also, that means you are defining the function fully. You get all the information about the function. So when you have complete information about the function, that is function definition. When you have very minimal information about the function, that is function declaration. When you are using the function, that is function calling. Okay. In this case, sum xy, it is taking two arguments, and then what is it doing? It is adding them. There may be another function which takes two arguments and maybe multiply them or divide them or perform any other operation, right? So here you are telling exactly what it does. So this is function definition. All right. So the parallels are in a variable, you just declare the variable, say int x. You don't know what is the value of that variable. When you say x equal to 5, you are initializing it or you are defining it. Okay. Or now you can separate them as well as combine them. Same with functions. You can separate declaration and definition, or you can combine declaration and definition. We will see that. And when you actually use x in an expression like x plus y or x plus 5, then it means you are calling x. You are using x. Similarly, you will be calling the function sometime. You're not declaring, you're not defining. That will be done only once. And then you can use the function any number of times. The way you can use a variable any number of times. You can call the function any number of times. Okay. So let's look at the parallels in programming. You already used one of these three things related to functions in your programs which you did so far. Which one is that? Is it function declaration or function definition or function calling? Declaration. Which function did you declare? Definition. Which function did you define? Any example? Main. Yes. Okay. Main we have defined. Let's keep main aside. Any other functions? Return. Return what? Return is a function. Any examples of functions you used so far? Yeah, sqrt, printf, scanf, they are functions. So what are they? Did you define them? No. Did you declare them? No. What did you do? You just called them. They are defined by someone. They are defined already in some file. they're declared in some file. Those are system functions. Those are inbuilt functions. You just call those functions. You just use those functions. Okay. So there are inbuilt functions and then there are user defined functions. So far, you dealt with only inbuilt functions, be it stdio functions like printf, scanf, or math functions like sqrt or par or ceiling or floor, or string functions like string copy, or char functions like to upper, to lower, is upper. All these are inbuilt functions in C. You have only used them. You have only called them. So you dealt with only function calls so far. You never declared or defined any function on your own. The moment you do that, it will be a user defined function. It will not be a system function. It will not be an inbuilt function. Okay. So now we will see how to define our own functions. Okay. And so far, the examples you used are like, say, printf or scanf or math functions or string functions or char functions. All these you have used. They are already defined. They are already inbuilt. You have just used them. You didn't change their definition. You didn't define them on your own. You just used them. Okay. So these are all examples of function calls. All right. So we will see how to define a function on our own so that this can be used later, either by yourself or by someone else. But before that, can anyone tell me why do we need functions? What are the uses of functions? Yes, reusability. You see, sometimes you may want to perform a task again and again. Like sum is a very simple example, like square root, right? Square root, these are functions like string copy. You want to copy from one string to another. If you have to write this function on your own, then you need to go through the array. You need to create two arrays. You need to see, go through the first array and the second array and copy each element from the first array to the second array, each character from the first array to the second array, and so on. You need to write a loop, right? Rather than that, you just use this string copy, give the two array names, two strings names, and it will do the job, right? Now, suppose if you have to do this multiple times, you have to write the entire code every time, the loop. Every time you want to copy one string to the other, right? So that will make your code more cumbersome. Now imagine if you want to do, say, sorting, or if you want to find the shortest path from one node to the other node in a graph, right? It's some codes are very small, 5 lines, 10 lines. Some codes may be 100 lines long. So every time you want to do this, you need to write those 100 lines every time, right? So that makes your code very cumbersome. So the readability of your code will be affected. But if you use a function is nothing but some sequence of instructions put in a block and a name given to that block. That's all. So that you can run that block again and again whenever you want, just by calling this name. So if you want to use the function 100 times, if your code has 100 lines, if your algorithm has 100 lines, say finding the shortest node, finding the shortest distance between again and again, then these 100 lines I need to repeat every time I want to do that. But suppose if I use a function, if I put this entire 100 lines in a block and give it a name, say a function, I only need to call this function 100 times, 10 times, 20 times, any number of times in my code. This 100 lines of code I need to write only once. That's all. I can call the function any number of times I want, right? So that makes my code more readable. I need not repeat the entire code again and again, right? That is one thing. So readability is one advantage of using functions. The second thing is, if you want to make any changes, say to that algorithm or to that code, if you are using that code separately, every instance of that code, say you are repeating that code 20 times, then you need to make 20 changes. In each instance, you need to go and make the change. Here you need to make the change. Again, in the next instance, you need to make the change. Again, in the next instance, you need to make the change. But suppose you are putting the code in a block, in a function block, then you need to make the change only in that block. And then you just need to call that function any number of times you want. So making changes will also be easy, right? Otherwise, every instance of that code, you need to go and make a change. And if you forget somewhere, the code is spoiled, right? So readability is an advantage, and then modification, easy modification is another advantage, right? And another thing, sharing with someone, portability. Like you see, when you install an app or a software, what are you doing? You are getting updates. When you get an update, they're not sharing the code with you. They're not asking you, okay, make these changes in your code, make these changes in your code. Then they need to do it for every user. They need to send the changes to every user, and they need to make it in their phone or laptop or whatever it is. But what are they doing? They're giving you only the function. When you are running an app, you are running a function. So whatever updates they are doing, they are changing the code at the backend. You need not worry about that, because all you need to do is just run the code, run the function. That's all. So the code is changed only once in the main function, but it is reflected to you even though you don't know what is inside that. So I can hide my code. I can wrap my code. So these are called wrappers. I can wrap my code in some name, and I just share that name with you. I give you only permissions to execute that. Actually, when you compile a C program, when you get a.out, I can share this a.out with you. I need not share my source code with you. You can run this a.out in your system also. If you have GCC in your system, you can not GCC. Basically, a.out can be executed. Any basic Linux or Windows, you can execute this a.out. Any exe file you can execute, right? You don't know the source code of the exe file. Like you're installing a browser, you're running a browser, or you're running a video player. You're only running it. You're clicking and you're running it. You're executing it. You're not compiling it. It is compiled already somewhere. So all you are doing is execution. So that is like running a command. That's like running a function. So I am giving you only the function, and I am giving you only execution permissions. I am not giving you read permissions. You don't know my code. You can only run it. You can use it, but you can't change it. You can't read it. That's why these are closed source. I mean, Linux, etc. They are open source, because not only you can execute the executable, but you can also go to the source code and modify it. That's why they are open source platforms. Whereas Windows, etc., they are closed source because they only give you executables. You don't know the source code. If you want to make any changes, you can't make. They need to make the changes and release the updates. Okay, so that's the difference. So functions, you can just share the function and the user can execute that function. If you want to make any modifications, you make it. The user need not worry about that. They just run the function. Okay, so these are all various advantages of functions. The more examples we work out, you will understand it better. All right, so these are examples of function calls. So far we only dealt with function calls. Now let's look at an example of a function definition. Let us assume so let's say I want to write a function for squaring a number. I want to take a real number and I want to square that number, right? So let me call my function as square. And another thing, so far we looked at some good coding practices. I mentioned them from time to time. A couple of things which I mentioned was indent your code so that it is easily readable. And second thing, add comments wherever possible, so that even when you come back to your code after 3 months or 6 months or a year, you'll understand what is happening. Otherwise, it's very easy to forget what you wrote the code for, what the code is doing. Okay. Now, the third thing is make your code as modular as possible. Modular means function. Each function is a module. So add as many functions as possible. In fact, each function should not have more than 10 lines. So the moment your code crosses 10 lines, create a new function. So if your code has 100 lines, it means you should have around 10 functions in your code, so that it is easy to understand each portion of the code, and it is easy to modify that particular module so that other modules are not affected, right? So another good coding practice which I'm mentioning now, is to make your code as modular as possible. It will be easy to modify it. It will be easy to read. It will be easy to share. Okay. So these are some good coding practices which you need to keep in mind when you are writing. You will understand them better when you learn object-oriented programming. There you will have functions, not only independent functions, but you will have functions associated with a particular object. So there are functions independent of objects, and there are functions associated with objects. Those functions which are inside an object, those are called methods. So there are private methods, there are public methods. Usually we share only public method to a user so that they can access only this public method, and they access the data only through this method. They don't have direct access to the object's private data. You'll understand them later when you get to object-oriented programming, but these are some things which you need to keep in mind when you're coding, some good coding practices. Okay. Anyway, and the function name should be meaningful. Rather than using ABC or FG like that, make the function name meaningful so that just by looking at the function, you get an idea of what the function is doing. Like if you see any of the inbuilt functions, printf, scanf, you get an idea of what it does. Printf prints something, scanf scans something, sqrt, maybe it's calculating square root. Ceiling, maybe it's calculating ceiling of a number, log x, log 10, log 2. They give you an idea of what the function is doing. They're not like a of x, b of x, not like that. They're not arbitrary names. So whether you know the function definition or not, just by looking at the name, you at least get an idea of how to use it, right? So the naming should be meaningful, be it of functions, of variables, or whatever it is. Give meaningful names. This is another good coding practice. Okay. So I want to square a number. I want to take a real number. I want to square it and return the value, right? So let's say this function name is square, and I want to take a real number. Real number means in programming either float or double. Let's take float. Let's say the variable name is x. All right. Now I need to do something with this variable. I need to square it and then return the value. So one way is I declare another variable, say float y equal to x into x, right? And then I return, what do I return? Y. Okay. Now this is my function. So, and what is the data type of y? Float. So the return values data type is also float. I need to mention that as well. So what will be the data type of input values? What is the data type of output value? This goes into a function's definition, and the entire block is also part of the function's definition. Okay. So this is an example of function definition. All right. Now, this same thing I can even sort of condense. Instead of using these two steps, I can just write one statement. Return x into x. It's not necessary that you calculate this value, store it in a variable, and then return that variable. You can directly return the value of the expression itself. Anything is fine. All right. Now, let us take another example. Suppose I want to write a function which adds a float and an int and returns their sum. Okay. So let me name my function as sum. Now it takes two values or two variables. One is float x, and second one is int. This order also is important. First input is float, second input is int. Okay. And what does it do? If you add a float and int, what will be the output data type? Float. So I can create another variable, say float z equal to x plus y, and return z. All right. What is the output data type? Float. So that output data type you should mention before the function name. Okay. Or you can combine these two. You can, instead of using two statements, you can write just one statement. What do I write? Yeah, return x plus y. Its value will be automatically float. So you can just write float here. All right. Again, this is another example of function definition. Okay. Now let's look at the declaration, only function declaration of these two examples. So for the first one, the function declaration will be, so for any function, you just take the first line. That first line is function declaration. So this is function declaration for this function definition. Or you can shorten it further. You just need to give the data types. You don't need to specify any variable names. Float, square, float. You see, basically the computer should know what is the function name, what are the input data types, what is the output data type. All right. Input variable names need not be specified in function declaration. They're optional because you're not going to use them. In declaration, you're not defining, right? You're defining means you should tell it what to do with the variables, what to do with the inputs. If you are not going to tell it what to do with the inputs, you need not give any names, right? But in function definition, you can't leave it like this, just as float. You have to give the name X because later you need to do something with that variable, right? You need to multiply X into X. If you don't give the name, what will you do inside? What will you use? What will you perform your operations on? Right? So you have to perform your operations on some variable. So that variable name needs to be specified in the function definition. But in declaration, you're not going to use that variable. You're not giving the body of the function. So variable name is optional, but variable data type is important. What kind of inputs do I expect? Do I expect a float or an int or an array or a struct or a string? What do I expect? I need to know that, right? So data types are important. Input data types, output data type, and the function name. These need to be specified in the function declaration. Okay. Variable names are optional in the function declaration, but in function definition, everything needs to be specified. Variable data types, input data types, output data type, function name, and even variable names. Everything needs to be specified in function definition. Okay. Similarly, for this function, what will be the function declaration? You just take this line. So this is function declaration for this function definition, or so either this you can use or the same thing you can repeat. Only thing is you can do away with the variable names. That's all. Either this or this. Okay. So anything is fine. In function declaration, variable names are optional, but variable data types, input data types, and output data type, and the function name, these are necessary. Okay. Now the question is, why do you need two things, function declaration and then function definition? Why? So we will see that. So the order in which you need to use these three things, or particularly declaration and definition, the order in which you can use them, there are two options. So the order of functions in your code so there are two options. First option is you give all the function definitions first and then write the main function. Okay, or the second option is you can write main function and all function definitions after the main function, but in this case it will throw a warning or an error. In your local compiler it may throw a warning, but on Euclid it will throw an error, because in main function you want to call these functions, user defined functions. Inbuilt functions also, you see sometimes if you don't include that library, what does it say? I don't know this function. This function is undeclared, right? Similarly, if you define the functions after the main function, it will say this function is undeclared. You're trying to use some user defined function, but this function is not declared, right? Because it is declared or defined after the main function. It is not visible to the main function. So for it to be visible to the main function, you should at least declare it before the main function. If you want to define it before the main function, well and good, then you need not declare separately. Definition anyway involves declaration. But if you want to define after the main function, then you should at least declare before the main function, so that you're telling the computer, I'm going to define it later, but I'm going to use such and such function with such and such name and such input data types and output data type. So at least you should give the declarations before the main, although you want to give the definitions after the main function. Okay, so in this case you have to give all function declarations before the main function, and then you can give function definitions later. Okay, this is for usable, this is for readability. Suppose I have very large functions, right? And I'm going to use those functions in my main function. So by the time I reach the main function, I should scroll through many lines. Rather than that, I just want to focus on the main function, and I will refer to a particular user defined function only if necessary. So to make it more readable, I will just declare all the user defined functions first and then write the main function, so that I access the main function as soon as possible. And then I will write all the large user defined functions later. If I want to refer to a particular user defined function, I will go to that particular function. Okay, just for readability. That's all. Or another reason is, sometimes, like I said, large projects are not done in one file. Many people work on a large project and many people write different codes in different files. So they may be using a common function. In that case, you define the function only in one file and then declare it in all the other files. If you want to, if you are calling that function in any other file, you just declare that function in that file and then you use that. Okay. So, or you include that function, you include that file as a header file in your code and then call that function. Okay. So these are various scenarios in which you want to separate function declaration and definition, or when you're working with multiple files, you may need to separate function declaration and definition. Usually in the same file, if readability is not important, you just define all the functions before main. As simple as that. But if readability is important, you just declare the function names in one line for each function and then write the main function and then give the function definitions. Okay, so we'll look at some examples now so that you'll understand better. All right. So suppose I want to, I'll just first implement the square function and the sum function. I want to square a real number. So I write square, my function name is square, and I take a real number. Real number data type in programming is float or double. We'll just go with float. I am defining the function first. So which means I need to give the variable name. I can't skip it because I'll be using that variable inside my body. So float x, and what do I do with the variable? I square it or multiply it, and maybe I can assign it to another variable, float y equal to x times x, and I return y. Okay, but y data type is float, so I need to specify the output data type also. Okay, so the function structure is, in the first line you give the output data type, then the function name and the function's arguments. Each argument you should specify the data type and the variable name. Okay, and inside the function body you say, then once you enter the function body, it is like any code like main function or anything. You do everything. You can do anything which you can do inside a main function. You declare other variables, you do whatever you want, operations you want to perform on variables, you perform all those, anything you can do. Finally, you want to return a value, return that value. All right, now I want to use this function, I want to call this function inside my main function, right? So a simple method is, I declare another variable, say float z equal to square of a particular number, say 5. Okay, I can give a number. I'm calling the function square, so I call it with a specific value, right? So when you are calling, you don't need to give data types. You should not give data types, either input data type or output data type, nothing. Only function name and the call input values. That's all. So the data types should be specified only during declaration and definition, never again. It is like again a variable. When you're declaring a variable, only that time you declare the data type of the variable, int, float, int x, float x, whatever it is. When you are using the variable, you never use those data types again, right? You don't say float x plus int y. You just say x plus y. No matter how many times you're using that variable, you use just that variable name. You never write the variable data type again. The only time you write the variable data type is during declaration. Similarly, the only time you use a function's the data types in a function inputs and outputs is only during declaration or definition. In all other cases, you never use data types. You directly use the function name and the argument values. That's all. So calling can be done any number of times, but declaration or definition is done only once, right? I print the value of this variable, right? That's it. So I gave a specific value. I called the function with a specific value. That function returned the square of that value, stored it in a variable. I printed the value of that variable. All right. Yeah. No, you can declare anything. If it's useful, you do that. See, another way is same thing. Whether this function's output is float or int or whatever, here you can declare anything. I can declare int x, I can declare char ch. It is like any other function. In this particular case, our return type is float. That's all. But just because our return type is float does not mean I can declare only float kind of variables inside my function. It is like any function. Yes. That int value has nothing to do with the variables I am declaring. It is whether my code is running successfully or not. Okay. Because main's definition is different. We don't know the definition of main. I mean, this is not actual definition of main. This is like, what do I say? Sort of calling main in some sense. Calling main with different values. I am filling the code with specific input, with specific text. The definition of main allows you to write this code when you call it. Okay. So, or let's say partial definition, main is partially defined. You're giving the remaining definition here. But whatever functions we are doing, we are giving the complete definition. We can't give partial definition. We are giving complete definition. Complete definition. That's all. You can't say I defined partially. Now I leave it to you. You give the remaining definition. No, that is main is special function. All other functions you give complete definition and then you call them. That's all. Okay. All right. So this is one way. Another way is I directly call the function inside my print statement itself. Right? Both are same things. Calling a function with a particular value. So now this is like an expression. This expression will have a value. So you can print that value, or you can use this as a part of a larger expression. You can use this as part of addition or subtraction or whatever. You can say square of 5 plus 32, something like that. So this itself becomes an expression. Okay. So that's it. This will also work in the same way. Or I will take the input from the user and I will make this code generic so that I don't say, okay, this code will be for square of 5, another code will be for square of 10, another code will be for square of minus 100. So for each number, I should write different codes. I don't want to do that. I want to write a generic code or a generic, it's like a calculator. Whatever input you give me, I will calculate and return the output to you. So that's what my code will do. It's like a small mini calculator or a mini software or a command, which does the job for you. You give input, I'll give output. Okay. So what we will do, we will say float a, and we get this value from the user. Let me say n, usually it's a number. And then all I need to do is write square of n. That's all. Okay. So I should give a value, say 4. It will give 16. I can give float values also, right? 2.5. It will give its square, and so on. Right? Now I can also sort of say, I don't want so many decimal places. I'll say just up to 3 decimal places. Again, that's up to me. It's up to me. Okay, that's all. So now the only thing is, this is like a command on its own. Actually, now this code which I am giving, it is like, you see, we have different commands, right? Like here I have different files, 1.3. You always see me copying one file to another file, right? So this is a command, 2 inputs. So this is like a function. Copy is like a function which takes 2 inputs and then gives an output where it creates a file with the second input name 4.c. It creates that file, right? So this is like a function. I will have many hundreds of such functions, and each of these commands are nothing but functions or codes, right? So these are meaningful names. So when I see CP, I understand I am doing some copy. Or when I say another command mkdir, I know I am creating a directory. Okay, say test. Now you see a new directory is created. Okay, so this is a command which I can run here itself. But basically, what is happening? This command is nothing but a particular function of a particular code. Some code has only this function as its main function. That code is compiled and given to me as an executable, and I'm executing it, right? Or say when I say ls, this is a command. This is a code. I'm just running the code. This is like /a.out. Only thing is that particular code's a.out is renamed as ls. Another code's a.out is renamed as cp. Another code's a.out is renamed as mkdir. Right? So these are all different codes. Their executables are given different names. For us, every time we compile, we are getting only one name for executable, a.out. Suppose I want to change that. Okay. Right now I wrote a code for squaring a number. I want to name my executable as square, so that when I run this executable, I understand that, okay, this executable will square a number rather than just a.out, which is very generic number. I get no idea from what a.out does. If I give a specific name as squaring, I understand that, okay, this will square a number. If I write another code, maybe like square root, I will name that executable as sqrt, so that I know this will calculate the square root of a number, and so on. So in case you want to change the name of your executable, you can do it. So when you compile, so what was the last code? Yeah, I remove this directory. Okay, so I compile. Normally, if I just compile it like this, I'll just get a.out. Okay, but I don't want a.out. I want a specific executable name. In that case, what you do, you say this anyway, you type, and then you say -o, whatever is the executable name you want to give that. I want to say square. Okay, now you see a new file came, square. So you can remove a.out. You just have square. So this square is your new a.out. So instead of running ./a.out, you run ./square. Now you give an input, it will give an output. You write another code. That code is probably doing square root. You name its executable as square root. Then you do ./square root. It will give the square root of the number. So whichever function you want to perform, call that particular executable. Now you will have different executables. So far, you have been having only one executable for the latest file that you compile. If you want to use another file, you have to again compile it, again get its executable. So every time you want to run different files, you have to run all of them, compile each of them, and run only a.out. Okay, but suppose I have 10 different files. I want 10 different commands for each of them. I need not run them again and again. I want to use square one time. I want to use square root another time. I want to use, say, cube root another time. I have 10 commands. Whichever command I want to use, I will use that. Again, I need not go to that source code and compile that and then again run a.out. No, once it is compiled, it is there. You can run it any number of times. That is exactly what is happening when you are installing a software, or when you are running a software. Say when you are running a browser, what are you doing when you are opening a browser? You are running the .exe file. That browser name may be Chrome or Firefox or Edge browser or whatever it is. When you are clicking, you are running that .exe file. So similarly, once you compile your code, so I wrote a square function. I can share it with you. You can use that function like a calculator. You can use it any number of times you want. You need not know the source code. I need not share my source code with you. I can just share the executable with you. You can run that executable any number of times. That's it. So I am charging you for that service because I am providing you a function to square a number, or I can provide you a function to sort a million numbers, or I can provide you a function to what do we say, to convert speech to text. So I'm providing you the executable. So you just give your speech as input to this file. It will give the text as output. But you don't know what is inside this executable. Even if you try to open it, it is not readable. Like you see this, the C programs which we write, these are readable. These are called source codes. But the executable which you create when you compile the C programs, that is not a readable file. Okay, you can't read it. You can't make anything out of it. So even if I share this file with you, I have no problem. You can't understand the source code. You can just run it. Okay. And another thing, I don't know if you ever noticed, you see the permissions here. These are called permissions, read, write, execute permissions. All these files have read, write, and then dash, minus. Minus means you don't have this permission. Each of these have a particular, the order tells you which permission is given. So read, write is given for this file, but you can't execute this file. You can read, write, and also execute. Okay, but actually you need not read, write, because anything, you can't read or write anything meaningful into it. So you can just change its permission to only executable and then share it with someone. They can only execute it. They can't do anything else. Sometimes even in Word or Excel, sometimes if a file is shared with you, it says you have opened it in read-only mode. You can't change it. So these modes are defined before sharing. You can set these modes, set these permissions. I can share a file with only read permission, or I can share a file with only execute permission. Okay. Now suppose this square or this a.out file, if I share with you with only execute permission, no read permission, no write permission, then you can't even open it. You can only run it. That's it. So it's up to me. Now, in this case, I don't bother. Even if I give read permission, even if you try to open it, you will only see gibberish because it's in binary. You can't read anything. You can't make anything out of it. So you can only execute it. That's it. So that is what exe files are. So only exe files are shared with you. Source codes are not shared with you. They never share .c or .cpp or .py. Right? You only get the executables so that you can run them. That's it. You can run them any number of times. You can't read them. You can't edit them. Okay. So that's the idea. You can rename the executable as your wish. So with -o parameter, when you compile, use -o and the executable name. So instead of a.out, you will get some other name. Instead of square, I can give some other name, square root. So you'll get two files. But in this particular case, both do the same thing. Only the name is confusing, but square root will also square the number only. Okay. Yeah. All right. So that is one thing. Now let's write another function. Let's say we want to add the digits, find the sum of digits of a number, right? So how do we do that? So suppose I take an integer and I find the sum of its digits and return that sum. So here input will also be an integer, output will also be an integer. Okay. Okay. Before that, let me just implement that sum function also. Sum, it takes a float and an int and it returns the float. So sum float x int y, and you just return x plus y. Okay. Now I take these two values from the user. So I say float a int b. You see, you can also use the same variables. It does not matter. This x and y are different from this x and y. This x and y will be visible to the sum function only if you pass it as input to the sum function. Otherwise, they will not be visible. So I scan these values from the user and I say x comma y. Okay. Instead of x and y, I can also give ab. Okay. This ab, when they get inside the function, they become xy. All right. So you can give same variable names. You can give different variable names. It does not matter. The variables which you have defined inside main are visible only inside main. The variables which you have defined inside function, user defined function, they are visible only inside that function. This is called scope of a variable. We will look at that in the next lecture. But giving same names or different names does not matter. So changing x and y in the main function will not change the x and y in the user defined function. Okay, they're just copies. Yeah. Name of the function as a variable. Sum is equal to x comma y. X plus y. It will give conflict. It will give a warning or an error. Because you sort of declared sum as a function, but then you're trying to use it as a variable. So it's better not to do that. Okay. Now let's see. Sorry, should not be given in the same line. So now I can give two numbers. First one should be a float. Next one should be an int. Okay. So let me remove this. Yeah. Mm. Mm. Yes. 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 Yeah. So let me show it. Now suppose I give this function after the main function. I give the function definition after the main function. Then what will happen? Here it is giving error. Why? Because it does not know that function. Okay. Sometimes it may just give warning, but in Euclid it will definitely give an error. So you need to declare that function at least before main, although you can define it after main. You either define it before main, then no need to declare. But if you are defining after main, then you should at least declare it before main. Okay. So in that case, so you can do this. Okay. This will work. Now no error, no warning also. This will work normally. Okay. Or you can just remove the variable names and give only data types. Okay. This will also work. Fine. Both will work. Both will work. In declaration, you need not give variable names. You should give data types. But in definition, you have to give variable names also because you're going to use them. Right? Yeah. So let's quickly work out this example, finding sum of digits. So I will define it. So input will be one number and output will be one integer. Output will be sum. So output is int, input is int. Okay. So let's say n. And how do I find the sum of digits of n? Divide by. How do I find sum of digits? We already worked this. Yeah, so you want to add one digit at a time, right? So it's easier to find the last digit. How? Mod 10. N mod 10 will give you the last digit. Okay. So you add this to the sum. And then now we don't need the last digit. So let's remove it. How do we remove it? Divide by 10. So you repeat this process. So first declare sum to be 0 and then add n mod 10 to it and then kick out this digit by doing n equal to n by 10. Now the second last digit will be the new last digit. Again do n mod 10 and then kick it out and so on. So repeat this process until n is greater than 0. Okay. So here we say int sum equal to 0 and while n greater than 0, sum plus equal to, you add what to sum? The last digit. How do you get last digit? N mod 10. I added the last digit. Now I want to remove it. How do I remove it? N divided by equal to 10. That's it. Finally, what should I write? Return sum. That's it. So now, suppose I say int n, I scan the number from the user and I just print sum of the digits of n. So let me rename this function saying sum of digits. Okay. That's all. All right. Now let's see. Let's say, what is the sum? 24. Okay. And so on. Right. So if I don't use this function, if I have to use this code, right? This entire code, I need to repeat every time I want to find the sum of digits of a number. And if I want to make any change, I need to make changes in all those instances. But here, I can make any number of changes within this function and the main function is oblivious to that. It doesn't matter whether you change that function or not. It will automatically reflect in the function call. So your readability is better and modifiability is also easy, right? So those are the advantages of using functions. Okay, so let us stop here.